Okay, here's a practice exam problem that seems to have caused a significant amount of grief, so I wanted to go through it. And it gives this molecule and asks essentially how many hydrolyzable groups and how many hydrolysis products. So down here, just to review, here's the hydrolyzable groups we've talked about so far. Acetal, hemiacetal, which we won't see much of, imines, enamines, and nitriles. So think about how all of these are formed. So an acetal, here's a cyclic version. You can take this ketone and react it with this diol in the presence of acid, and that ketone carbon becomes the acetal carbon. Similarly, for an imine, you take the ketone, react it with a primary amine, and you get an imine. And then for an enamine, a ketone plus a secondary amine gives you the enamine. All of these reactions are kind of the forward direction. The reverse reaction is a hydrolysis. So if I were to take this acetal and add acid and water, we're just doing the reverse reaction. We're breaking this acetal apart, we're breaking those two bonds. This carbon becomes the carbonyl, and these two oxygens come off as the alcohols. Likewise, the imine, we're breaking it here. The nitrogen comes off to give you the amine, and this carbon becomes the carbonyl if you're doing the hydrolysis. And then the enamine, it's the same deal. If we hydrolyze, you're breaking that bond between the carbon and the heteroatom. That carbon becomes the carbonyl, and the nitrogen comes off as the amine. The other hydrolyzable group that I'll mention here, which isn't one we learned to make, but the nitrile is hydrolyzable. So we'll just look at it in the hydrolysis direction. Okay, so here is the carbon, in this case triple bonded to the nitrogen, but nonetheless, in hydrolysis, you're essentially breaking that bond. And that nitrile carbon, it actually becomes a carboxylic acid, so it's a little different than the others. And then the nitrogen comes off as the amine. All right, so applying this to the problem up here, we have the acetal, or the cyclic acetal, which is hydrolyzable, and we have the enamine. So we're basically just doing these reverse reactions. So highlight your acetal carbon and highlight your enamine carbon. So we can break these bonds during the hydrolysis. So those break off, and this breaks. Those carbons that I highlighted in blue become carbonyls. Here and here. The alcohol doesn't get affected. So we get a carbonyl here, carbonyl here. All right, the pieces that broke off, we have this alcohol, but it's actually a diol, so we'll break it off. And add hydrogen to each side so that oxygen has its two bonds and it's happy. And then we also have the amine that broke off. and we need to add 1 hydrogen to that to make it happy. So we end up with 3 products after hydrolysis.